Hello everyone, thanks for watching the previous video, whoever have watched it. As promised in the previous video, now in this current video I'm going to tell you the logic for the remaining steps in the simplex procedure. Meanwhile, let's just quickly recap the procedure in the next 5 minutes, and then we can go ahead for the discussion about the logics that are involved while we are preparing the simplex table. So this was the question that we had, where we had a maximization objective where we wanted to maximize our profit, and it was subject to these conditions, and it was originally an inequality where we converted this into an equality by adding slack variables s1 and s2. This s1 and s2 are simply indication of the idle resources. So s1 was indicating idle raw material, s2 was indicating idle labor hours, and in that way this component indicated the raw material utilized, this indicated the raw material remaining idle, and in that way total raw material was 16, and same goes with the labor also. Then we converted this into the first simplex table, which was the starting point of our simplex, where we said initially when we are understanding or when we are trying to analyze how much should we be producing, that time we started with that, let's say what is the current situation. So the current situation, it was 0 units of x1 and x2, but in simplex we always start with the slack variable, and since we were not producing anything, all the resources were idle, so 16 units were idle, profit 0, and then we prepared this. And as we have discussed earlier, program column s1 and s2 idle resources, 0 profit, 16 quantities, and these numbers indicated the sacrifice ratios, or this 4 indicated that I need to sacrifice 4 units of idle raw material to get 1 unit of x1. Same way I need to sacrifice 2 units or 2 kgs of raw material so that I get 1 unit of x2, and same goes for even s2. And for s1 and s1 we said it is 1, and then we said cj was the gross benefit that we were supposed to get. If I produce and sell x1, the profit that I get is 3. If I produce and sell x2, the profit that I get is 4. And zj, we have already seen, this was the opportunity cost, because if you want to produce x1 you need to sacrifice s1 and s2, so the profit that you were earning on s1 and s2 needs to be sacrificed or needs to be given away. And since at the first stage there was no opportunity cost, so even s1 and s2 were having a profit of 0, therefore there was no opportunity cost, and the net benefit we decided out of 3 and 4 is going to be the most beneficial, so this was selected. And accordingly this 4 indicated that we want to produce x2, but now how much quantity of x2 to be produced, that was given to us, or that was calculated by us using replacement ratio. We know this replacement ratio was simply quantity divided by this, because we had 16 quantities of 16 kgs of raw material, and each unit of x2 required 2 kgs of raw material. So 16 by 2, that's 8, and then 16 by 3, that's 16 by 3. So out of these two we knew that we are going to select the lowest positive, and we selected this, that is we are going to produce 16 by 3 units of s2. And then we calculated the fixed ratio, and then we did with the in and out. After that we went ahead with the table 2, and as I've told you, in the table 2 what we have basically done in the previous video is just calculated the numbers. We have simply calculated the numbers, and as I have promised you that I'll be giving you the logics of those steps in the subsequent video. So this video is dedicated to that logical interpretation part, where we are going to see how these numbers are derived and what are the logics for it. Okay, so let's go ahead with it, guys. Starting with the x2 part. As we said, we need to sacrifice. In the first table we said 16 by 3 is the quantity of x2 that needs to be produced, and we can observe that there are 16 by 3 units in the quantity column for x2, right? Then talking about these numbers now, uh, these numbers, basically before we go to this sacrifice ratios, let's first target this part. Let's first target this part as to what is this 16 by 3. So as we said, the decision that we took in this table, we decided to produce 16 by 3 units of x2. Now let's understand the repercussions of this. If you're producing 16 by 3 units of x2, can you tell me how much raw material used and how much labor used? How much raw material used and how much labor used? Because we need to understand that if you're producing 16 by 3 units of x2, both of them have been used for it. So if you look at our original question, we will find that each unit of x2 required 2 units of labor, 2 units of raw material. So each unit of x2 required 2 units of raw material. So the raw material consumption over here, we say for 1 unit it is 2 kg. So tell me, for 16 by 3 unit, how much raw material should have been used for it? So definitely 16 by 3 into 2, so that's 32 by 3. So raw material used is 32 by 3. So here we say that there are 32 by 3 units of raw materials are used. Now if I talk of labor also, we can understand that each unit of x2 consumed 3 hours of labor. So we said 1 unit is equal to 3 hours. So if you're producing 16 by 3 units, that should consume 16 hours of labor. So if we say what is the total labor or total raw material available, initially we had, as we observed, 16 units. So we had 16 units of raw material and 16 units of labor. So if I say what is the balance left out, so you'll say 16 minus 32 by 3. So basically that is 16 by 3 units of raw material are available, and 16 minus 16, the labor is fully utilized, which we have observed even in the first simplex table. So that's 16 by 3 units is what we look at over here. That's the number over here. That's the available quantity of raw material. Now let's understand what these numbers are in the main body of the table, where we have the sacrifice ratios between each one of them. Let's understand that. First, let me just erase this part. Okay, let's go ahead with this part now, where we say, let's understand these numbers right now. At this stage, as we observed, there's no S2, meaning that the labor, hours are not available for the production. So definitely if we want to produce x1, we need to have a labor force. So we know for 1 unit of x1, raw material and labor, there's a requirement of raw material and labor. So we say that for 1 unit of x1, the raw material that was required was 4 units, or I can say 4 kg and 2 hours. So that is 4 kg and 2 hours. Okay, then look at over here where we say raw material is requirement is 4 kg, labor is 2 hours, but for 1 unit of x1 labor is right now not available. Labor is right now not available. So what shall we do, sir? So definitely what are we supposed to do is, if I want to produce x1, I need to sacrifice some units of x2 because I need to have that much labor released from x2. That much labor to be released from x2. So as we observe, we need 2 hours, whereas the labor available is 0. So for 2 hours of labor, how much you need to understand, for 2 hours of labor how much x2 should be reduced. So we know 1 unit of x2 is equal to, if you observe 1 unit of x2, that is 2 raw material and 3 labor. So that's 2 units of raw material and 3 hours of labor. So now I definitely don't want to release 3 hours of labor. What I want is only 2 hours of labor. So if I say 1 unit of x2 is equal to 3 hours of labor, but what we need is just 2 hours. So for 2 hours, for getting 2 hours of labor, how much unit of x2 should I sacrifice, or should I produce less? Can I say we should be producing, or we should be reducing our production of x2 by 2 by 3 units. So can I say 2 by 3 units of x2 will be giving you 2 hours of labor, right? So that's where we say I need to sacrifice this 2 by 3 units of x2. I need to sacrifice this 2 by 3 units of x2, 2 by 3 units of x2 to get 1 unit of x1, because I need labor to be released from there, and then only we can produce x1. So that's where we observe you need to sacrifice 2 by 3 units of x2 to get 1 unit of x1 because of requirement of labor hours. Okay, then coming to this number 8 by 3. So why is it this 8 by 3? Why is the ratio between S1 and X1 is now 8 by 3? So as we have observed over here, or we have decided that we need to sacrifice 2 by 3 units of X2 to get this 2 hours. Now suppose if we reduce our production 2 by 3 units of x2, we said it is equal to 2 hours of labor, and also plus it was equal to 2 hours of labor, and also we can say 2 by 3 multiplied by 2 kg raw material. So raw material is 4 by 3 raw material. So 2 units of x2 if produced less will be equal to releasing 2 hours of labor, which will be utilized for producing x1, and also 4 by 3 raw material will be released. 4 by 3 units of raw material will be released, because if we are going for reducing production x2 by 2 by 3 units, not only labor will be released, also raw material will be released. So if you think, what is the raw material required for 1 unit of x1, raw material required for 1 unit of x1, we know that raw material required for 1 unit of x1, it was 4 kg, but am I going to use this 4 kg fully from the idle raw material S1? Of course not, because if I am reducing my production of x2, 4 by 3 units of raw material is already getting released. So 4 by 3 is already getting released from x2, that I will utilize for producing x1. So 4 minus 4 by 3, if you do it, That's simply you can observe 8 by 3 is the sacrifice ratio between S1 and X1. In this way these numbers are arrived at, where X2 and X1 sacrifice ratio is 2 by 3 and S1 and X1 sacrifice ratio is 8 by 3, because we won't be needing entire 4 kg of raw material now, for a fact that if you are producing less of X2, I will be getting 4 by 3 units of raw material released, and that can be used for producing X1. Therefore I'll be needing only 8 by 3 units of S1. So that's the reason for these numbers. And anyways, we know this 0 1 matrix thing, where we say the sacrifice ratio between X2 and X2 is 0. By using S1 you cannot produce any more X2, because whatever possibility was there, that is already covered up. Coming to S2, S1 and S2, you observe that it is minus 2 by 3. Now how is it minus 2 by 3, sir? If I sacrifice 1 unit of S1, how can I produce 2 by 3 units of labor? That's possible because over here you observe that 2 by 3 is a number. So this S1, if you use S1, if you sacrifice S1, that will lead to reduction in S2 by minus 2 by 3. So that is this number which is arrived at. And similarly, even the next table logic also goes on the same lines. So I've tried to give you an insight into to some extent of the logic that is there in the simplex method. What's more important is for you is to understand the procedure that we have, the step-by-step procedure that we have. Just keep a flow of it, so that we can discuss the next type of simplex method in the next video, where we are going to have the next video on the minimization method of simplex. Thank you everyone. See you in the next video.